Good morning, folks. So we're going to talk about how to add fractions and how to subtract fractions with regrouping or borrowing, depending on what your personal need might be. So we're going to start off with some regular proper fractions that are not mixed numbers. Again, the first thing we're going to do, and we talked about this earlier, was to make a common denominator, because two fractions can't be added or subtracted until they have the same denominator. It's like comparing apples to oranges. They're both fruits, both fractions in this case, but you really can't compare them. So we're going to find what the common denominator is of 4 and 6. Now we could use the LCM idea, the least common multiple. Least common multiple of 4 and 6. We list our 4s, 4, 8, 12, 16. List our 6s, 6, 12, 18, 24, and we find that 12 is our least common multiple. Now, we also could use 24. It's also on the list, but the better one to use is going to be 12. So if we go ahead and do that, we are going to make both of these into 12s or 12ths. Sorry, we're still adding them. That hasn't changed. Now, the big thing here is how to make 3/4 into something over 12 and how to make 6ths into something over 12. Well, in order for 4 to become 12, we have to multiply it by 3 over 3. You're still multiplying by 1 essentially, but we're just rephrasing it as 3 over 3. So 4 times 3 is 12. That checks out. 3 times 3 is 9. 6 becomes 12 and multiplying by 2. So we multiply our second fraction by 2 over 2. That becomes 10 twelfths instead. When we add these, we get 19 twelfths. We can then convert that to a mixed number. 12 is into 19 one whole time, with 7 leftovers out of 12. It's always worth checking for simplification, but in this case that is a simplified mixed number and a simplified improper fraction. Both would be okay, depending on the situation. Now, what happens if we have a mixed number? Like 1 and, no, I don't know, let's go with 3/4, same thing, plus, I don't know, 4/5. Just go with that for the sake of argument. It's going to work the same exact way. Now, some people will say you always have to make them into improper fractions. You can make this into an improper fraction. I think it's extra work, because then you're converting back to a mixed number for no reason. Instead, try this out. Same concept. You're still finding the LCM, or the least common multiple, of 4 and 5. 4, 8, 12, 16, 20, 24. 5, same thing. 5, 10, 15, 20. The LCM is going to be 20. So we can make these both into 20ths. Now notice, that whole number 1 stayed there. I didn't change anything. There's a reason for it. Give me some time. 4 becomes 20 by multiplying by 5. So multiply 3/4 by 5 over 5. We get 15 20ths. We do the same thing with 4/5, which multiplies by 4, which is now 16 on top. When we add those, we get 1 and 31 20ths, because 16 plus 15 is 31, and that 1 is still right there. Now this is a funky fraction. 1 and 31 20ths, that's a mixed improper fraction. Ain't no one like that. So here's what we're going to do. We're going to take that 1 and 31 20ths and set it up as two different items. Separate them using addition. 31 20ths becomes 1 and 11 20ths. That 1 is still there. It's very consistent throughout this problem, which gives us now 2 and 11 20ths. I really like this method. It makes a lot of sense to me, and practically it's way less work than converting to an improper fraction the entire time. My personal opinion about that. Now, this also works when we're subtracting. So let's say we have 1 and 3/4 minus 5/6. We'll keep those same numbers that we used last time. Okay. Same deal. We're still going to convert to an improper fraction. Again, that common denominator is still 12, so we'll keep that 12. We'll keep that 1 whole. We'll turn both fractions into 12ths. Convert. This is times 3 over 3, which makes 9. This is times 2 over 2, which makes 10. Now, this is where a lot of people get stuck, because they say, oh my god, I have 1 and 9/12 minus 10 twelfths. I can't take away 10 from 9. That's not going to work. I'm going to have to go negative. I don't like negative numbers. You don't have to. Pause. Think about it for a second. When we're doing regular subtraction, let's say 31 minus 17. Okay? I know that's unrelated to our problem. That's okay. We can't do 1 minus 7 using the algorithm. So we historically have always borrowed from the 3. Not writing. Don't know why. And make it a 2. Then we give 10 to 1 and make it 11. Then we can subtract. We know this. This is how this works. We can do the same exact thing with our fractions here. Because 9 isn't big enough, we go next door, we borrow from the 1, make it a 0. But we're not adding 10 to 9 here. This is where a lot of people get messed up with this method. Instead, because you're taking away 1 whole, and we're talking about 12ths down here, 1 whole is the same as saying 12 over 12. So you're going to add 12 over 12 to 9 twelfths as a mechanism for borrowing. This is kind of like turning into an improper fraction a little bit. 9 plus 12 is going to be 21 over 12 minus 10 twelfths gives us 11 twelfths. So this does work. Now in this case, that was just making it into an improper fraction. That is true, but this also works for bigger numbers. So let's go with 3 1/3 minus 1/2. Okay. Again, common denominator is going to be 6. So that's 3 and something over 6 minus something over 6. This times 2 times 2 makes 3 and 2/6. This one's times 3 over 3, which makes 3/6. Again, same situation. We have too many that we need to subtract in order to subtract. What do? We go next door to 3, we borrow, make it 2. Now 1 whole in this case is 6 over 6. So we're going to add 6 over 6 to our fractional part. This is now a 2 because we borrowed, and here is now 8 over 6. It looks funky, but that's okay. It won't be funky very long because now we have enough in our numerator to subtract. 8 minus 3 is 5/6, and that 2 minus no wholes is still 2. Way less work than going to improper fractions. What happens if they're 2 mixed numbers? 4 1/4 minus 2 3/5. Again, start the same way. Common denominator, which here will be 20ths. This is times 5 over 5. This is times 4 over 4. It makes 12. Again, we don't have nearly enough in that numerator 5 to give to 12. So we borrow. Make it a 3. 1 whole here is 20 over 20. So I'm going to add 20 20ths to my fractional part, which makes 3 25 20ths minus 2 12 20ths. Same deal. Now we're off to the races. 25 20ths minus 12 20ths will give me 13 20ths. Whole number, 3 minus 2 is 1. I think this method is a lot easier than doing improper fraction the whole way. That's just my personal opinion.